All right, let's go. Guys, I can only assume that all of you use LLMs. And well, they are known to be by now better Stack Overflow, better than books, better than asking a rubber duck or whatever. So we basically assume that they know everything. But let's start by saying, okay, what they are, because there's always this one person who doesn't know, or 10. So LLM is a large language model, like your ChatGPT, Llama, or BERT, or whatever. It's a machine learning model which can process and also generate human language. All right, but there are in fact things that LLMs don't know. So whatever you don't post on the internet, they don't know, at least most of that. So if you have any secrets, or if your company has any secrets, LLM won't know about that, and it won't be able to reason or talk about your secret stuff or your personal notes. So actually, they know everything, almost. So let's build an LLM which knows a bit more. Hi, my name is Paweł. I'm a CTO at Visuality, as the same company that Mariusz comes from, and I'm also involved in Ruby Europe. I, for example, maintain the site. If you'd like to get involved into helping with the RubyEurope.com site, I strongly invite you to. Today, I'm going to tell a story which will show that my LLM is smarter than yours. All right, but what's a presentation without showing a product, right? It's all academic if there's no product. So let's build one. So let's meet Ragnar, trademark. Ragnar is actually your assistant, as most LLMs are. It actually will know all about your company secrets, all about internal policies, deep dark secrets, and he's available, helpful, and a bit sarcastic. Because why not? So we have to start with a plan. So we have to take an LLM, we have to add internal knowledge of our company, let's see how, add some UI, ship it, and bask in fame and glory for a long time. All right, so first of all, we have to choose an LLM. And when I'm choosing an LLM, well, I don't go dig the internet, I just choose ChatGPT, because that's the only one I really know. Of course, there are like llamas and all, and I've dealt with that. But LLM, hey, we know that, we can sell that to our bosses. All right, so we are done with that. Now we have to add internal knowledge. I don't know if you guys ever messed with machine learning, but the first thing that came to my mind was to fine-tune the model. So we can further train a model to add the knowledge, but that's hard. And actually, it gets harder if you ever want to change the model. Or maybe a new model comes to the market, maybe ChatGPT for something else, and you want to apply your changes to your fine-tuning to the model. It's just hard, it's pricey, and we can talk about that over a beer. There's a link which you can read about it. So no, we are not doing that. However, when you're asking a question to an LLM, you have this prompt window. So you can put your question. But in fact, if you could put all the knowledge about your company before your question, LLM would actually be able to take the answer from all that text that you provide about your company. So let's do that. So we have our question, and we put context with all the things that we know about our company. And then we ask the question. Let's see how it works. So we have a proof of concept, we get our financing, we get ChatGPT, all knowledge, ask questions, and this looks about like this, a library put behind a ChatGPT. So it's, of course, a failure. Thank you very much. No, we can do it better. We can prepare relevant context. From the entire library of data, which comes from our company, we can choose only the relevant part. We can put it in the prompt, and then ask a question. And LLM is smart enough to take out the answer from that context, that fine-tuned context, and answer our question. It would look like this. So again, we have the context, we have the question, and the answer. The context is about the company, how it started, and who has founded the company, the question asks, and the company was founded by someone. This is actually from ChatGPT, an example. So we can do that. That's technically possible, but how? And I'm going to spend the rest of the presentation describing that, and a few other things. But okay, sorry guys, this is for me. Okay, let's do it. So LLMs understand text, human text, right? We've all been there. But it has one more additional feature. LLM can express a phrase as an array of numbers. So we have, for example, a phrase, a dog eating a shoe, right? Oh, yeah. Given that to ChatGPT for all, we would get this array of numbers. So this array of numbers expresses a dog eating a shoe. Every number in this array is some dimension of a piece of knowledge. So this phrase, all the dimensions you can imagine, like this is something about an animal, this is something about the shoe, about eating right now, it's all expressed in these numbers. So this array of numbers is actually called an embedding. So it's a vector, and from now on I'll be using a vector term, not an array, of floating point numbers, and they represent the semantic meaning of the data that you've put before. One great thing about such a vector is that it can be compared with others. So we have two phrases represented by two vectors, and we can compare them. But embedding is not an LLM term, it's a mathematical one. Again, something for a beer. I asked ChatGPT to express me this concept in more human terms. So I asked for animals and some meaningful dimensions, like cuteness, danger, size, friendliness, and intelligence. The numbers were a bit surprising. I won't get into details very much, but apparently Black Widow is more cute than King Cobra, but King Cobra is a bit more friendly. Nevertheless, there is puppy and there is bunny, and let's concentrate on those. So there is cuteness, danger, size, and so on. When we take, even in our human minds, if we take all those numbers and add them together, we can sometimes figure out what this animal might be by comparison with others. So if we have this example, if we have something as cute as a bunny but a bit less cute than a puppy, more danger, bigger than puppy and bunny, as friendly as a puppy, and even more intelligent than puppy. Any guesses? Dog. Exactly, it's a dog. At least that was my example, and that was what I thought. So you can see, you can do the same thing as LLM. You can compare, and you can figure out stuff. All right, but it's a Ruby talk, right? So let's see what we can do with Ruby. There is a wide-known Ruby OpenAI gem, which you can just require, and you can ask any LLM to generate an embedding, so a vector of numbers. In here, I've given it an input. Ruby is great for writing AI software. Ask for to generate an embedding, and I got a vector with more than 3,000 dimensions, and the first 6 is here. All right. Then, if we have those vectors, we can compare them for similarity. There are so many measures. Today we are using this because of, well, too long of a story. Two methods that we're going to use alongside the presentation, and I won't dive into them later on. So just to get embedding, we ask an LLM about embedding and wrap it in a vector class. That's it, from phrase into a vector. And second, cosine similarity, we give it two vectors and we get back a number, which I can show you an example of. So we have two phrases. Ruby is great for writing AI software, and as I've heard, in Madrid, life's best moments start with tapas and friends. So we just take those phrases, get embeddings of both, and measure cosine similarity of both. And apparently it's not very similar because it's a number between 0 and 1, but still we can do better. Let's take a look at a few other examples. So, New York is a city in the USA, a cow goes moo. It's like, apparently it's more similar than those two previous sentences. Maybe there are some cows in USA, who knows? But it gets more and more similar as the semantic meaning of two phrases gets more similar. And for me, the most interesting one is the last one. It's the same question. I won't butcher my Spanish or your Spanish. There are two sentences, and as far as I understand, they mean the same. But if you look at the phrases, they look nothing like it. So, the similarity is quite high. This is how LLM can translate your language. In fact, it can get any language and it will understand the same things. I could put Chinese in here, which was also an idea, and it would still work. All right, but can it help Ragnar? How am I doing on time? Not bad. All right. Remember that library of data that we had from our company. So we can split it into pages. I will show you how in a second. But imagine like tons of papers, tons of digitalized papers. We can just split it page by page. And if we have a question, like what kind of vacation request can I submit? The first page is about company policies, how it started. The second one, no, it's about how the company was started. The second about submitting leave applications. And the third is about harassment policy. So we get a question, what kind of vacation request can I submit? LLM doesn't know that, doesn't know it about our company. But we can calculate embeddings of each of those, all those texts, and an embedding of the question. And we can compare. So we can compare which of the pages is most similar to the question, and well, apparently it's this one, and for good reasons. If we compound the prompt, this is how you do it. You put a context, you put the knowledge, then you put your question, and you kind of prompt the LLM to answer. But this is technical stuff, but still it works like this for usually. So we put our knowledge, we put our question, and we got the answer. And let's just take a look how it would look like in Ruby. So we take Ruby OpenAI gem. We have our client, which is an OpenAI connection. We choose the model. We put our compound prompt, and the answer is you can submit requests for various types of leave, including vacation, sick leave, and personal time off. So basically, we got our answer directly from our company's policies using the same ChatGPT. But there was one more request. We were supposed to be sarcastic, and I wouldn't miss that. So we can embed that into our compound prompt as well. So we have additional instruction. Put the entire answer in a big sarcastic tone, which gives us an answer very similar to the previous one, but it starts with, oh, you know, just the usual type of, dear boss, please let me escape this office. And it goes on in this manner. So basically, we've just completed our task. What we used, the procedure or the type of application that we created is called Retrieval Augmented Generation, RAG in short. So this follows exactly the procedure that we've just done. We examine the question, we retrieve additional information, we augment the prompt with context, and we generate the answer using an LLM. Okay, so that was the theory. Now the fun part. We have to store embeddings. And guys, there was an article floating around, just use Postgres for everything, and it applies here as well. So Postgres has an extension called pgvector, which you can just install. It's very good for storing vectors. You can index them up to like 2,000 dimensions, I think. But if you really want to, you can use also, of course, MySQLite or Maria or MySQL. But they have experimental features. In Postgres, you have out-of-the-box pgvector, which you can just add. And in Rails, because why not, it would look like this. This is all you have to do to add pgvector to your Postgres database. Once you have this, You can, for example, create an active record. Let's call it item, because why not? So we have an item, we add a column to that. Well, let's call it embedding with some dimension. Once we have that, we can use our OpenAI client to just get embedding of a dog eating a shoe, once again, into that, and we have this data embedded and stored with our item. Let's say that this dog eating a shoe is something descriptive of our item. Then we can find similar items to that one in our database by using another gem, because, well, we can do that manually. It actually works, but why not? Why not use a gem? Get a neighbor. It has this Rails-like syntax, so you can just apply has neighbors by the measure of embedding. And if you take your item, you can find nearest neighbors, and you can apply whatever distance measure you want, and you can retrieve as many of those as you want. You can, from that, comes something that actually will probably change your life in some way, and this is called vector search. I can only assume that most of you have either used, implemented, or heard of Elasticsearch or OpenSearch by this time. So we've went so far to use Elasticsearch's full text search, and this is better. Because when you have a vector search, it's saying, okay, I have an item with an embedding. I want to search for, let's see an example, an innocent-looking puppy. This would actually find me a puppy eating a shoe. I don't even have to search for something similar. It just has to have a similar meaning. So in some contexts, I have a demo in a second. This is better than full text search of any other sort, because this does something that I was trying to achieve before, called fuzzy text search. So find something similar to. This is how you do it. You use your neighbor, you get, again, nearest neighbors of a phrase, or of an embedded phrase of your choosing. All right, guys, but all that was used. I used Ruby and Ruby OpenAI Gem, which is kind of the hard way. Sometimes you can go even without OpenAI Gem, because you can just call an LLM using a REST call, because why not? Why not? Getting embedding is just a REST call to LLM. But there is an easier way, and you can use it at least sometimes. LangChain, some people describe it as an ORM for LLMs. So basically, you have very simple functions to interact with LLMs. It's a widely known gem, and I won't talk to you much about it, but it's just simpler. So you use a gem, LangChain.rb, and you can embed any phrase very similarly to what I've done before. There is, of course, more. You can use it for chatting with an LLM. You can provide it a whole array of history of conversation. But again, can it help our cause? Yes, it can. And I will show you how the entire application of Ragnar, the entire product, can be solved in actually 3 lines of code, if you put everything in 1 line. So using LangChain, you just have to do 3 things. First of all, you have to connect to an LLM of your choosing. Again, I'm using OpenAI's ChatGPT. The second thing is you have to choose the vector database of your choosing. In here, it's pgvector, the one that I advertised for. So again, we have ChatGPT and we have pgvector. So basically, if you have like a Rails application, that's the same database that you've already used. You provide a URL to your database. Index name, this is the table that you're going to put your embeddings in. And you connect this to an LLM. This way, you can create you can push all the company secrets into your database. You just need 1 line. then one line is you use the database, this is the PG vector variable, at data, and you just put files or anything for this matter. This is one of the PDF, the second one is a text file. What it does, what it will do, the database, which is the PG vector related variable, it will split the file into chunks, again, by pages, right? So it would split a PDF into chunks. Each of those chunks will be embedded and will be put into the data, into exactly this table. So in this table we have like ID, the chunk of PDF of the text that we've put, and the embedding. Now we can search for chunks of our knowledge using LangChain to answer Ragnar's question. And this is all automatic. You do it once. It's kind of like seeding your database. Whenever your sources of knowledge change, you just redo it again once, and you have the entire database of embeddings, and you can look for questions. And maybe a demo? I think we have time. Yay! Okay, let's do it. So I've created a small application. It's open source actually. So it shows vector search and RAG. You can you can download it. Maybe beforehand I can show you one more thing. I can show you what I've. Okay, sorry for chaos for a second. Let's start with this. So I created an application about rags, which are pieces of clothes in English. Each of them is described, has some condition, color, size, and so on. I've taken all this information, like description, condition, color, and size, and I created embeddings of that and stored with each rag. Therefore, I can use vector search for this. There are different, there are like 20 of those, and you can imagine someone coming to your page and looking for something for a birthday gift. You wouldn't optimize your database for this question, right? But maybe I can. If you read in, like if you see what it returned, I asked it for three options. The rag is smooth surface. It would be a great gift. So out of this, our vector search mechanism was able to match something for a birthday gift. The second one, I don't know why it returned. It's just nice. The third one says, among other things, it would be a good option as a souvenir. So you can use embeddings as vector search with the vector search to find things. It's not perfect. If I put green or yellow, I think I tested at some point. So it returned green and yellows, but if I put just green, it has too little context. So among this entire description and color, apparently saying yellow, the second one says green. You have to find your balance. Something as simple as green, given the entire context of a big description of an item, might not work perfectly. So you perhaps need to work on this prompt, this search phrase, and you have to adjust it before actually pushing it into your queries. All right, nothing to see here. All right, we found the library of company secrets. I actually trained this RAG application, which we are about to see, on three things. First, a book I found on the internet, like a 60-page PDF book. Second thing, and this is what I wanted to show you, is I think it's called Secrets. Passwords? Oh yeah, awesome. So I have 3 files. One of them is called passwords. And the second one is, I think, called phone book. So plumber, local restaurant, and Ruby specialists. And I also put a PDF book, something, about something. I actually haven't read it. But those are the green or yellow. Okay, so we can ask, and this RAG knows about the book and the secrets, company secrets. So let's start with the book, like who are the main characters? Yeah. The main characters in the provided context are Ruby, Tech, and Claire.
Oh. I don't see it. Yes, sir. Go.
Who do you want to talk to ask about? Ruby. Oh. That was too easy. All right, so I'm asking who is Ruby. Ruby is a character who appears as the artificial being or entity and something else. I've just put a book, and LangChain has put it into chunks, and this is how we can answer. We can ask it. Like there is one more thing. It also has this, for example, passwords, pin code for the cookie jar. Let's ask about that. How to get to the cookie jar? To get to the cookie jar, you should use the pin code provided, and this is the pin code. So you don't need elaborate preparation. It's just a text file, and provided to RAG, it's actually, you can actually talk about getting to the cookies. So yeah, good luck with that. All right, guys, just to finish, 3 minutes. This is just the basic mode, like RAG 101 if even. Because for any Ragnar, there is a bigger guy on the block. And actually, there is so many things you have to know about to put it to production. First of all, do not use ChatGPT, like never for that. You probably should host your own LLM somewhere in the company network, and we can talk about that. Hopefully there is beer. And you have to, maybe sometimes these documents are not that easy to put into chunks. You have to summarize some of the content. And again, you can rewatch this presentation and read it. I'm running out of time. But there is so much things that you actually should learn before going maybe to open internet. If you just need it for internal reasons, go nuts. All right, thank you very much. And thank you for having me.